Alright, so for this first part, we're going to be looking at the graph of x squared. This is known as the parent graph. We'll see hopefully why in a little bit. Well, I'm just going to say it now in case I forget. It's the graph that we're going to base everything off of later on. So it's like it's the parent. It's where everything comes from. So for this, I'm going to plot some points, and I already know what this graph looks like, so I know what points to plug in. I'm not going to have you like pick those on your own, at least not now, because I mean I'm picking them specifically so that when I do plot them and draw the graph, it'll show me all the necessary parts. But that's because I already know what this looks like, so I know which ones will show me the necessary parts. But what I'm saying is you won't have to come up with these. But if I plug in 0 to that, 0 squared is 0. Plug in 1, 1 times itself is 1. Negative 1 times itself, negative 1 times negative 1, that's a positive 1 still. Okay, and I plug in 2 and I get out 4, because 2 times itself is 4. And negative 2, well, negative 2 times negative 2 times itself is still positive 4. So I have that, and now I'm gonna plot that. And I have my coordinate plane there. 0, 0, that's easy. And I'm going to do it in red. 0, 0, great. And then 1, 1, right there. And there. Negative 1, oh yeah, I did negative 1, 1. That's back 1, up 1. That's why I did that. 2, 4. I'm just plotting these. Over 2, up 4. So that would be there. And then negative 2, up 4. That's back 2, up 4. And I'm going to make it curved. So a nice parabola looking thing right there. Now, for the next couple of problems that I'm going to do, really it's going to look, I hope you can see this. I'm not sure if you can actually, if I'm recording, but I'm moving the graph around. Actually, I bet you can't see it. I don't know. If you can see this, it's like the parabola is being shifted. It's just like sliding around. That's what's happening with our next couple problems. But if you can't see that, then all of that didn't make sense, but don't worry about it. I'm going to explain it. So the next thing that I want to do, this is just an explanation of what's happening. You're not going to have to do this on any of the homework assignments. Like, you don't have to plug in points. You don't have to plug in all this stuff. But first, okay, we looked at that. That's what this looks like. Oh, this is my alarm to tell me to make a video, which I'm doing right now. Alright, so the next thing I want to do is compare this graph to the graph of, let's do it in blue, f of x equals, let's say, x minus 2 squared plus 4. Alright, so I'm going to do the same thing, and again, I'm coming up with these numbers. I'm not expecting you to come up with these numbers. So the first number that I'm going to plug in is 0. 0, and I'm going to plug it in to here. Now, normally you would do this in your head, but if I plugged in 0, you would get 0 minus 2, quantity squared, plus 4. Well, that's negative 2 squared plus 4. That's 4. Negative 2 times itself, that's 4, plus 4, that's 8. So I get, come on, I'm busy. I get, to delete. I get 8. So here, I would put an 8. If I plugged in 1 minus 2, it's negative 1. When I square negative 1, it becomes positive 1. And then plus 4, that's 5. Hopefully you understand what's going on. 2, if I plug in 2 there, it becomes 0. 0 squared, okay, that's 4. Plug in 3. 3 minus 2 is 1. So 1 squared plus 4, oh, that's 5. Hey, that's the same as that. And then 4. That's, oh, when I plug it in, I get a 2 squared, 4 is 8. Look, that's the same as that. Look, this is the vertex. This is the center of my parabola. And then these are the same, so it like branches out and goes up the same way. So here I've plotted these I guess plugged in these numbers. Those are things that I'm not going to require you to get. This is the vertex here. It's at 0, 0. We'll look at that later. But now I'm going to graph this just to see what happened. And then we're going to do another example the short way. So if I plug this 0, 8, that's 0. It means I move nowhere. And then I go up 8. And there it is. 1, 5 means I move over 1, up 5. That's right there. And then I have 2, 4, 2, 4, over 2, up 4. I have 3, 5, 3, 1, 2, 3, up 5. And 4, 8, 4, 8. And then I have this. Nice parabola. Look at that. It's the same thing, except for this moved up and over. And now I'm going to think about this. First, I'm thinking like, okay, where did I start here? 0, 0. That's known as the vertex. So the vertex here is 0, 0. Here, if I start here, how much do I have to move over to get to this vertex? So how much do I have to move to the right? That would be 1, 2. So I have to move to the right 2. That's interesting. And then this vertex was there. How much would I have to move upwards to get to this vertex? Well, that would be 1, 2, 3, 4. That's interesting. 2 and 4. Those numbers are right here. Oh my goodness. It happens that if you have it in this form, you can just see what's happening. This tells you that we are moving, or move. What do we move? We move to the right. Move right 2. And that's because it's negative there. It's kind of backwards. Like normally you would think, oh, it's negative. That means to the left. But in this case, for the x's, like when it's on the inside of the parentheses, that means it's backwards. Here, this 4, it's plus 4. That means move